So, hello
Yeah.
guys, how are you today? We hope you are doing well. Thank you for your
Uh-huh.
time. Thank you for your interest, and welcome to GLC Networks webinar. We much appreciate for your join. Today webinar will be discussed about OSPF versus BGP on Mikrotik. So, if you have any questions and other things, you can unmute yourself or just drop your message in chat box. So webinar today will be delivered by Mas Ahmad Mardiansyah. He is a co-founder of GLCNetworks. He is also trainer, mentor, and consultant for IT and ISP, more than 10 years experience. So are you ready with your slide?
Yeah, sure. We can
Okay,
start.
let's begin. Enjoy the
Uh,
webinar, guys.
yeah, thank you very much, admin. Okay, guys, so let's get started. Yeah, as I promised, today we will be talking about BGP and OSPF. Sorry, I have some issues here. Sorry. Okay, let's get started. So the agenda will be, we'll be talking about a little bit about the routing review. Okay, so for those who are new to routing protocols, perhaps you already learned something. We'll do some review here, how the routing works. And then we talk about what's the difference between IGP and EGP. And then more technical, getting more technical. We talk about BGP and OSPF. And then after that, talk about some tips and tricks, how we run BGP and OSPF hand in hand. All right, so let's continue. Okay, first, what is GLC? For those who are new to this webinar, we are GLC, Garda Linsa Cakrawala. We are based in Bandung. Our areas are trainings and IT consulting. We do Mikrotik, Ubiquiti, and Linux things. We also have products, GLC Radius Manager, and then our regular events are um, a workshop, and then, of course, the webinar. My name is Achmad Mardiansyah. I'm based in Bandung. I'm Linux user since 1999. Yeah, it was a long time ago. Yeah, so it looks like I'm old now. Yeah, in 1999, I was using Red Hat 5.2. I still remember that. For those who are also trying Linux at that time, you might be using Mandrake, Linux Mandrake, Slackware 8, or Debian 3 or 4. I don't remember. And the FreeBSD, if you use FreeBSD, I think it's still FreeBSD 5 or 4. Okay. And then I use Mycotix 2007, and then Ubiquiti, and then yeah, I have CCNA as well. You know, standard things, standard networking guys. In 2003, yeah, that was my first CCNA. At that time, there is no exam dub, man. So you have to really learn your certification, unfortunately. Now it's very easy. You got the packet tracer for doing the uh, the practice. Okay, but here we are not talking about Cisco, right? So here we're talking about Microtik. Okay, so I'm also do teaching. Yeah, teaching Microtik, and then especially networking, not only Microtik but other vendor as well. Also Linux, and then programming. Okay, so guys, if you have LinkedIn, I would like to connect with you guys. Hopefully, it opens a new opportunity in front in the future. We don't know. Okay, so if you have a LinkedIn account, and then yeah, I would like to connect with you. Our past experience, we do things related to networking, like network support, integration, migration in Malaysia, in Africa, in Europe. And about the webinar itself, we started from 2010. Um, yeah, our first webinar was in New Year. Yeah, so we don't have things to do during the New Year's. Okay, let's do the webinar. Right. Okay, next is your introduction. Thank you. Thank you very much. I can see Yeah, from introductions, I can see some words are familiar. Okay, usually the participants are from Africa, from Europe, from Africa, from Ghana, Senegal, Congo. Some are from Kenya. I don't know if there is anybody from Middle East. I never see Middle East guys from here. Oh, maybe other person working in the Middle East. From Europe, I can see from Slovakia, from Bulgaria, yeah. And then from Pakistan, from Bangladesh, of course, from Indonesia, from previously from I saw people from Malaysia, from Singapore was very rare, Philippines, and then also sometimes people from Taiwan and Australia. Right, thank you. Right, thank you very much for your introduction here. Really appreciate that. So hopefully you can get something useful here from the webinar. Okay, let's continue. So as prerequisite, this presentation is not for beginner. Oh, okay. So yeah, I think I have changed the things here, but it looks like I haven't saved it. So basically, you need to know about the networking first, okay? Because this topic is advanced topic. So at least if you have a certification, at least you are qualified for MTCNA and MTCRE. MTCNA means Mikrotik Certified Network Associates, and MTCRE means Mikrotik Certified Routing Engineer. Okay, so but at least you know how routing works, how OSPF works, perhaps some little bit about BGP, and yeah, that's all. Okay, if you are really new, you don't know what is the routing protocol, and you don't know what is the IP address. Oh, okay. So yeah, you need to know that kind of knowledge first. Okay. Okay, so that was about the prerequisite, and then about the routing review. We will be reviewing some principles of how routing works. So first, we need to differentiate between router and routing. Okay, so router is the device, and then the routing is the process. Okay, so this is the router. Okay, the physical router. If you use an icon, and then this is the icon looks like, but look, the icon is round, but the physical router is square. So how come? Well, that's that's the router. That's the icon. Okay, so yeah, I teach networking, and then when students see the router icon looking around like this, they think like, okay, the physical router is also uh, have a round shape like that. So it's not like that one. The physical router usually is like a computer, rack based. So usually they are put in the rack, or it can be desktop based. So they are putting on top of a table, or hanging on the wall, or or any other places. So that one is not a problem. So that's the router itself, the physical device. And then we talk about the routing. Okay, so the processing, sorry, the routing is the process for selecting path for traffic in the network. So you have incoming packets, okay, coming to the to the router, and then you have in, and then you have out here. So what are the things that is coming in and out? It's the packets. Packets is layer 3. So I assume you already knows what is layer 3, otherwise you will get lost. All right. So usually when we draw our topology, so we do things like this. Okay, so you have a typical connection. Sometimes we call it physical connectivity or physical topology. So here, with this kind of diagram, you put everything physically in the physical. So for example, you have a switch here, You have an access point here, you have another switch, you have a router. So everything that can be seen physically, you put it there. Okay, and then put the cables, how this cable connected to that device, and then how the device connected physically. So everything physical, you put it here. So we call it physical topology, right? So everyone knows that, right? And then we talk about the logical topology. So previously, when we talk about physical, it's just only layer 1 and 2. But when we talk about logical topology, we talk about the layer 3. Okay, so we are not, we cannot see, we will not see layer 2 or layer 1 devices here anymore. What you see is just the layer 3, which is the IP address, the protocol on layer 3, which is the IP. So Internet Protocol. And then what the protocol contains is the network addresses. So you have a network here, network there, and then they are connecting to each other. Okay, so how many networks here? So we have 4 networks, right? And then these 4 networks will be connected to each router. And then we also know that each router has their own IP address. Okay, and then that IP address will be used as a gateway in order to send packets from one network to the other network. So for example, this router 1, it's connected to 192.168.1.0 and then connected to 192.168.0.0. Okay, so here is 26/26, here is /24, and then so on and so forth. Okay, so based on those topology, we put the topology into the network routing table here. So on router 1, there will be a routing table like this. Okay, so which is saying that, okay, you have a destination address and then here's the gateway. Okay, so where do you want to go? And then here's the portal to go to the particular network. Okay, so basically the routing protocol itself, actually it's depicted the logical topology of the network. Okay. So when we are doing forwarding packets, it works like a firewall. So when a computer is always working based on the bit, only 1 and zeros, but only 1 and zeros, but yeah, but the way we put the prefix is using decimal. So I think I see some of you are here and new to the network. So my suggestion for you is thinking like a computer. So thinking in 1 and zeros, thinking in binary. So everything you see in the routing table, you convert it into the binary address. So for example, this one, it's a /32, so you convert it into the binary format. Okay, and then when packets arrive, and then there will be a process for matching the destination address to the routing protocol here. Okay, so this is, for example, this is router 1, this is router 1's IP address. I'm in routing tables, and then a packet here needs to be matched on against the routing table. So which entry, and then we have to match the destination IP address with the destination prefixes on the routing table. Okay, so for example, here the destination is this, and then we check the first one, is it same? Is it match? Okay, if it is not match, and then of course we don't use it. Okay, let's check. This one is 0, this one is 1. So it's different, so we don't use this entry. And then we check another entries. We check again, is it same or not? It's not, and then we continue to the next one and then to the next. So you can imagine that if we have lots of prefixes here, and then there will be a long process if one packet arrive. Okay, so router needs to check the whole routing table. So on which entry the packets, the arriving packet match. And then, oh, okay, so if match here and then send it to this gateway. So that's what happened in the all routers in the world. So the more prefix entry you have, the more processing, the more RAMs you will be using. Okay. Guys, if you have any questions, and then you can type in the group chat or use your microphone. Next is in Mikrotik, where do the routing table lookup happen? So it happens in here. Okay, so the routing decisions arrive here. This is a packet flow for Mikrotik. So packets arrive in the input interface, and then we have a pre-routing chain. Okay, and then routing decisions, and then forward, and then the post routing. So for the new user, usually you need to be able to differentiate what's the difference between input and forward. Okay. Okay, so this is where the routing table lookup happens. So every packet arrive. So as you can see, routing table lookup will be done every time a packet arrive. So if you have 10 million packets arrive, and then the routing table will be read for 10 million times. Okay, so for that one, you need to have a very powerful router that can do that job. Okay, so that's the difference between cheaper router and then expensive router. Usually, based on the CPU power and then other features. For Mikrotik, um, the different all features for all Mikrotik routers are open. The difference between them is just the hardware capability. So cheaper router usually only have a small CPU clock, okay, but high-end routers tends to have more processing power, okay. Okay, so yes, in the routing table itself, we know that there is one parameters called distance. Okay, so previously we only know that the destination address and then the gateway, but the third parameter here is called distance. Yeah, it's basically it's saying that how far the distance for that particular prefix. Okay. Guys, this is just for review. Okay, so I assume you already know that this kind of stuff. So it's just for review. Okay, so next, again, the administrative distance is considered, um, distance, and then what is the units? Actually, there is no units, even though it's called distance. Yeah, distance. So when we talk about distance, we talk about kilometers, right? We talk about the meters. From America, they call it miles, okay? Inches, foot, and then so on and so forth. So here, administrative distance is just a value, So there is no, so it's called dimensionless, but it's still there, okay? Yeah, it shows that the distance of that particular prefix compared to others. Okay, so this is one parameters that is considered by the routing table whenever they have a same prefix. If you have a destination, a similar destination, two prefix that has similar destination. So for example, you have a routing table, right? And then the destination is 10, 10, 10, 0 slash 24. Okay, so gateway is 1, 24. You have another 10, 10, 10, 0 slash 24. The gateway is dot 2. But here, destination is 200. Here, destination, yeah, not destination, distance. So this is the distance, this is the gateway, and then this is the destination. Sorry for that. You have a 200, here is 110. So you will pick this one. Why? Because the distance is lower. Yeah, that's similar to what happened in our daily life. If you want to go from A to B, you will be picking the routes that has the lowest cost, right? So the lowest distance. And then we talk about the static routing. So static routing means you log in to every router, you create the routing table manually. Okay, so it's a very tedious task. If you have small amount of routers, you can do it manually, no problem. The good thing about the static router is you have a full control. Okay, if something happens, and then yeah, you are the one who will be blamed. Yeah, but the positive thing about the static routing is you have a full control. Okay. Yeah. For example, sometimes there is a bug on routing, dynamic routing, but because the you are doing static routing, and then you will be responsible for that. So the bug is on you, not on the routing table, because you're not using a routing table anymore. Okay, so you are purely using your knowledge for setting up the routing. Okay, and then we have a dynamic routing here. You don't have to log in. You don't have to create the routing tables yourself. So you go to every router, activate the routing protocol, and then the router will talk to each other to set up the routing table by themselves among. So they are talking to each other and to set up a, uh, to set up a table for all of them. Okay, if all of them have the same knowledge of the topology, basically this is topology, right? So when we talk about the routing table for the whole network, we can say it's a topology for network. All right. Yeah. So it's important to note that routing is done one way only. So, for example, so this is computer A, this is computer B. Okay. So from A to B, it goes through here. Okay, so from A to B. But from B to A, the path is this. Okay, so as you can see, routing is only one way. Okay, forwarding process on router is based on the destination address. See, so we are destination address based routing. So we are routing on a destination address. So there is an idea. Okay, what if we do routing based on the source route? Okay, so we are doing routing based on the source IP address. Yeah, if we do this, and then it will be very, very good, because yeah, there will be no spam, there will be no there will be no DDoS attack. Okay, so currently many crimes on the internet is happening because we are doing routing based on destination address, right? If we do routing based on the source address, I think it's much better. Okay, because we know that, okay, if you are coming from there, we do this routing. Okay, again, there is no guarantee that incoming path, because routing is one way. So there is no guarantee that incoming path is similar to the outgoing path. So again, we have incoming, we have outgoing here. There is no guarantee that incoming and then outgoing uh, is the same path, is following the same path. Okay, so that's why what we can control is only outgoing traffic. We cannot control incoming, because the incoming traffic is responsibility of other routers, right? Other routers outgoing. That's our incoming. Understand? Right. Okay, so next, let's talk about IGP versus EGP. So before we start talking about the difference between them, we talk about the AS. So AS, what is AS? AS is autonomous system. Okay, it's the definition is a collection of routers and network under one administration and apply single routing policy. So if you do policy routing, and then most likely all routers in your AS will do the same things. Okay, same policy. AS is identified by number. Okay, given by RIR, Regional Internet Registry, either Epinik, Erin, RIPE, or what else? Oh yeah, LACNIC, or if I didn't mention some, Afrinic. Okay, yeah. So you guys talking to them, and then they will give you, okay, here's your AS number, and then here's your IP addresses. Yeah, it's still continuation from the previous slide. So internet is based on IP, okay, IP addressing scheme, and then IP was defined in RFC 791. So you guys see here the small number, okay, small number, usually very old. It's in 1981, a very old protocol, and then still being used today. So as the, yeah, similar to the other principles that if you have addressing, and then the addressing has to be unique, right? If you have a street and then the street has a house number, okay, the house number should be unique. Okay, there is no unit that has same number, exactly same number like other units. Okay, otherwise the courier, the delivery guy will be confused. Okay, where is number 5 here? We have 3 number 5. Same thing with the IP address. Okay. Okay, so if it has to be unique, and then there must be an international body that regulates the IP address. Of course, yeah, it's called IANA, Internet Assigned Number Authority.
Assigned number authority.
Okay, I still hear feedback here. Yeah. Okay. So IANA is the is the main organization that regulates the IP address. So everything is controlled from IANA. But IANA itself will be delegates the responsibility to regional, and then regional will delegate to the countries. So here we have ARIN for North America. We have LACNIC for Latin America. For Europe and Middle East, here you have RIPE NCC. For people from Africa, you just call Afrinic, and then we are in Pacific, Asia Pacific, we contact Epinic. Epinic is located in Brisbane, Australia, but we are here in Indonesia. We have our representative of Epinic it's called IDNIC, Indonesian Network. I forgot the abbreviation. It's IDNIC. It's for Indonesia. Okay. Any questions so far? Or somebody got lost up to this point? No? Okay, great. All right, so let's talk about IGP and EGP. So IGP, interior gateway protocol, EGP, exterior gateway protocol. What's the difference between them? IGP runs internally within AS. Exterior gateway is between AS. Okay. So IGP connects network between AS. EGP is AS to AS. Example protocols, RIP, OSPF. Example EGP is BGP. Okay, EGP, BGP. IGP, OSPF, IGP, RIP. Okay, so please do not confuse. Okay, so this is how it looks like. Oh, okay, I have question here. Does EGP same with ERGRP? No. Okay, I put here. Sorry, I put comma here. Comma EIGRP. Yes, or I think IS. Okay, please do not say this is ISIS. Okay, this is IS. What's the abbreviation? IS. Inter. I forgot the abbreviation. Please say. Could you please help me? What is IS? Intermediate system. I forgot. Okay, sorry guys, I forgot this IS. Okay, so IGP is for interior gateway protocol, so it's run internally within AS. Okay, like RIP, OSPF, IGRP, ISIS. Yes, thank you, Lucas. Intermediate system or to intermediate system? Yeah, right. But I think, yeah, to some extent, yes, yeah. So currently, we call it de facto, okay? De facto for EGP, yeah. EGP is BGP, okay? Is the de facto, okay? So de facto means based on the many implementations, many applications. As de facto, people use BGP because, you know, internet is run based on community. Okay, it's not run by particular country. It's not run by America. It's not run by UK. It's not by Europe. Not by many countries. No, it's not. The way internet runs is based on community, and then it's run by IANA here. Okay. So IANA says that, okay, we are using IP addresses, and then it is free from other intervention. Okay, so internet is run based on community. Okay, because we need to have a connectivity, and then we do connect. We set up a cable connection between us, and then this is the protocol that we are using for communications, and then we set up a communication. As simple as that. Okay. Yeah, so this things is kind of confusing. So we have IGP, EGP, BGP. Yeah. Yeah, so please be careful for that, okay? Yeah. So basically the routing protocol divided into two groups, yeah, okay? Two main groups. First is for interior, a second for exterior, okay? So for interior is running within AS, for exterior is between AS. Okay, so this is how it looks like. You have one AS. This is your AS, right? Oops. Oh, I forgot to turn on the annotation. Okay. Okay, so this is one AS. Okay, here's another AS. You have things with the red color here is one AS. So one AS only only consists of one router. Other AS 3 routers like this. Okay, this AS has 1, 2, 3, 4, 5 routers. Okay, so here this is the EGP. Inside you are running IGP. Okay, so you're running OSPF here. Okay. You cannot run OSPF between this AS and that AS. Okay, so because there will be one router that connects to the other AS, so this one will become ASBR. Okay, and this will be the ASBR, AS border router, autonomous system border router. Okay. So there's ASBR is just the border router. Sometimes we call it border router. Okay, so this is how it looks like. Okay, how you connect between one AS to the other AS. All right. Oh, okay, yeah. So actually, this one is too advanced, so I should talk about this in later slides. Basically, this slide is talking about the difference between EGP and an IGP. Yeah, but it's okay. You get my point. Later on, we'll be talking about the scope and target scope. Okay, let's talk about the BGP and OSPF. So this is what we this is the topic tonight, right? So BGP and OSPF. First comparison is the working layer. So BGP actually is working with the layer 4. Okay, so layer 4, if it is layer 4, and then you have two options, either TCP or UDP. BGP using TCP, if you use TCP, and then there will be a port that you will be using. Okay, so this is TCP, and then after that, after TCP is established, and then you have a session. Okay, so I think in my perspective, BGP is running on layer 5. There's a session. Okay, and then this is, for example, you are setting up with Kimru. Well, OSPF, there is no dedicated session between routers. It's working on layer 3, actually between layer 3 and 2. Okay, because it just broadcasts, not broadcast, it's multicast using 224 or something, right? 224.5, either 224.6. Okay, so that's the OSPF. And yeah, so actually OSPF is a face-to-face protocol. Okay, while in BGP you can set up indirect BGP, but in OSPF you cannot do that. You can talk OSPF directly with the other router that is directly connected to you. Yes, thank you, Lucas. 224.0.0.5 and then 224.0.0.6. Yeah, yeah, this is what I'm talking about. Yeah. So inter-AS and then intra-AS. So BGP is mainly used for between AS. So this is the place where BGP runs. You run BGP here between this connection. But inside the AS, so here you'll be running OSPF. Okay, so it's intra routing protocol. So BGP is for inter-AS. But BGP can be used also for intra-AS. Yeah, I also run BGP internally. Yeah, inside my network, my network and my client's network. Yes. And then also, and then we have, yeah, so here is the BGP itself. Okay, so BGP can have IBGP and EBGP. Okay, so IBGP and EBGP. As I said before, BGP can be used internally. So this router here can run two protocols, so BGP and OSPF. So same thing here, BGP and then OSPF, BGP and OSPF, BGP and OSPF. Yeah. So the BGP here will be classified as internal BGP, but the BGP here is called eBGP because it has connectivity with other AS. Okay. So that's just the difference between the BGP. Depends on the peer that BGP has for exchanging the routing. Is it possible not to run BGP inside? Yes, it's possible. So we're just running BGP on the border. So this is just BGP, 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 BGP. Yeah, it's possible. What if you have a customer here? So let's say, so you have a customer here. Sorry. So you have a customer here, C. C is a customer, and then the customer connect to here. And then the customer has AS number. They have AS number, and then so this is how you connect to them. So it means that this is the ASBR. Okay, so this is the becomes the border router, and then you run BGP here. This is the BGP. What about this? So this is on the OSPF, right? Okay, so that's the difference. Next is from the routing perspective. Yeah. So, for example, routing BGPs. So BGP routing is based on the AS number. So BGP will see the whole AS number as a single unit. Okay. While OSPF will do we'll see each router as a single unit. So this is one hop, one hop, one hop, one hop, one hop. Okay, if we use OSPF, which path do we use? So we are using this path. Okay. Why? Because it's more shorter, only 1, 2, 3 hops. Okay. But for BGP, BGP will see whole AS number as a single unit. So even though this is 3 routers, BGP will see this is a big router. Okay. So you have here, you have here, you have here, you have here, you have here. So if you use BGP, what happened? This is what happened. Okay. So BGP will see the whole AS number as a one single unit. So the routing between router 1 and router 2, if you use BGP, will go this way. Okay. So with BGP, we just see the whole AS number as a single unit. Doesn't matter how many routers inside. Doesn't matter. Okay. Yeah, so this is path determinations, and then the topology. So the way we built the topology, if we use BGP, we can only exchange information to the peer. Okay, so if we have peer, who's it speaking here? Somebody wants to say something. Sorry guys, I think I have to mute your microphone. Okay, anyone? Okay, I have to put your microphone off. Okay. Okay, so everything off. Okay, great. Sorry guys. So that's the difference between the BGP and OSPF. So the way BGP works is we just exchange the routing table into our peer. Okay. So we send to here, we send to here. That's it. We don't know what happened after that. Okay. What happened after this? What happened after that? We never know. Okay, so that's what happened with the BGP. So other AS is their business. So I just talk to this AS only. Okay. But with OSPF, if we run OSPF, information is flooded to all other routers. Okay. So with multicast, you send multicast here, you send multicast there, multicast there, multicast there. So every router will get a multicast packets. Okay. So that's why when we talk about OSPF, it's very fast when we talk about the convergence time. Because if link is down here, and then the information of the link, if the link is down, will be flooded to everywhere using the LSA, right? Still remember that? What is LSA? Link state. I forgot the link state advertisement. Yes, yeah. And then you have LSA 1, LSA 1, LSA 2, LSA 3, 4, 5, 6, 7, 8, right? Okay. Yeah, I mean you can check documentation. how many LSA does the OSPF has? Right. So that's how OSPF and BGP built their own routing tables. All right. And then yeah, this is what I'm saying. Actually, it's not BGP versus OSPF, but actually it's BGP is working hand in hand with OSPF. So internally within AS, you're running IGP, Interior Gateway Protocol. In this case is OSPF. Mikrotik only supports RIP and OSPF as their IGP. They don't support, Mikrotik doesn't support EIGRP. Why? Because it says not Mikrotik. Cisco proprietary EIGRP. Mikrotik doesn't support ISIS. Why? Because, well, you can run OSPF. I mean, yeah, instead of putting two internal two routing protocol IGP at the same time, and then most likely people just use OSPF. Mikrotik, I think, decided that to support only RIP and OSPF only. So the Mikrotik doesn't support the ISIS or ISIS. Okay, so yeah, so when we talk about the OSPF and BGP in every prefix in the routing table, so there will be a scope and target scope. Okay, so BGP actually is, as I mentioned previously, BGP is only responsible for border. Okay, this is where you run the BGP, right? So this is just a border router. So that's why when you run BGP here, it will give the, I mean, still remember that the IP address on the router will be used as a gateway, right? So we have a gateway here, gateway IP address, gateway. And gateway is the IP address that is attached on the router interface, right? So let me change the color. So when you have a router here, and then you run OSPF here, OSPF, this is also OSPF. You will see there is a gateway also coming here, but the gateway is here. So this router here, will see the gateway. If you want to go to this destination address, the gateway is this one, recorded in this router. and then it's not correct. Why? Because it has to be directly connected. So for this router, the things that will be used as the gateway is the IP address that is connected directly to the particular router, right? In this case is this one. So if you have this router, let's say router 2, router 2 only have 2 options as the gateway, or 3 here. So you are using this, you are using this, you are using this IP address as a gateway, right? But when we run BGP and OSPF at the same time, you will see that the address will be the gateway that is located outside of the network, okay, outside of the AS. So that's why we need to update the target scope. Okay, so here we BGP and IGP, we run BGP here as well, so that when we run iBGP with a different scope, we can have a recursive routing in particular router so that we can find out which gateway to reach the destination. Okay. Well, actually, this recursive routing is called recursive routing. Recursive routing is advanced topic. Okay. At least you already have an experience with the BGP and OSPF so that you can see the difference between them. Okay. Next is things related to load balancing. So if you run BGP, BGP has rules, and then that rules determines how BGP select the best path. Okay, so it's called best path algorithm for BGP, and then by using that, if we have if we have two gateways, we just only pick one. Yeah, I mean that's, yeah, that is sad. Okay, I understand. But yeah, that's what happened. That's what happened. It's designed by BGP itself. Okay, you just only have one routing entry. Only one routing entry is chosen. It doesn't have support for ECMP. ECMP is like you have run router here, and then you have another router, let's say router 2, router 3, okay, and then here and here. If you have ECMP equal cost multipath, okay, you first connection to here, other connection to there. So it's a connection-based load balancing. Okay, so OSPF can support this. Okay, we can use ECMP. Okay, so sometimes it's go here, sometimes we go there. Depends on the how many connections we have. Okay. What else? Okay, yeah. I think that's all. Those are the comparison between the BGP and OSPF. So we talk about the difference between them. Okay. And then tips and tricks. Yeah, these are some tips that comes to my mind. Actually, there are some I forgot to put here. You can use loopback as a connecting interface. Yeah, first, do not distribute BGP into IGP. Okay, and do not distribute IGP into BGP. Okay. Do not use IGP to distribute customer prefix. Okay. Okay. So customer prefix, every customer has AS prefix. Okay, so this AS prefix needs to be carried by BGP. Do not use OSPF for carrying this. Okay, carried by BGP. So because BGP currently is the only one the one and the only routing protocol that carries the routing table of the internet. Yeah, there is no other alternative yet other than BGP, unfortunately. Yeah. Next step is using aggregation. This can reduce the total number of prefix. Okay, so you have /24, /24, /24, /24. Okay, so you combine them into /22, /22. Sorry. Okay. Yeah. So instead of you are announcing okay /24, 24, 24, 24. Why don't you just aggregate the /22? Okay. You have /22 network. Okay, that's good. You just announce /22. Don't split them, and then you announce each of the subnetted prefix individually. So it will, if everybody does this, and then it will reduce the total number of prefix announced. So currently the BGP is 600,000 something, yeah, almost 700,000 now. Yeah, so few years ago it was 500,000 routing entries for full BGP routes. Okay, that was aggregation. Next is use routing filter. Routing filter is for security, for protection. Okay, so for protecting you from the internet. Yes, that makes sense, right? Because there are bad guys over there. Okay, that makes sense. And then protecting the internet from you. Okay, so how come? Well, that happens sometimes. Yeah, BGP incident happened several times because human error. So that's why we need to protect the internet from you. Okay, so use routing filter. Be careful when interoperability with issues, BGP between vendors. So you have Cisco and then Mikrotik. They are BGPing together, and then yeah, I mean, yeah, just be careful about that, especially with administrative distance. Of Cisco and Mikrotik has the same administrative distance. So for example, BGP is 200, BGP is, I think it's 20, right? Yeah, Cisco is the same, but other vendor might be different, okay? So be careful with that. Next is loopback, okay? So if you run iBGP, better if you run on loopback network. Why? Because it gives you more flexibility. So it means that you are announcing the IP address on loopback, okay? So your loopback IP address will be announced on your IGP protocols. Okay, next, what about asymmetric routings issue between OSPF? Some best practice, please. Okay, so for asymmetric routing, I think what you can do. Yeah, okay. So for example, from router 1 to router 2, okay, so this is router 1, router 2, you have 2 links, and then automatically if OSPF do this, OSPF will do ECMP automatically. But if you prefer something, and then you will using policy routing, so you have to create a custom routing for particular traffic. I want to go through this way, for example. Okay, hope that answered questions. I mean, here I'm not saying that I'm also still learning. So I'm learning from many engineers here. Yes, so if you have more suggestions, and then you're most welcome. Right. Next, can I connecting between AS or router using L2TP without using BGP or OSPF? Yes, it's possible. Yeah. Yeah, it's possible. So you as a customer, I have a question from Andre here. So okay, let's draw a. So look, this is one AS. Usually one AS represents one ISP. Okay, this is ISP. So where are you? You are here. So you are customer, and then you connect to their network, right? Using what is it, L2TP or PPTP? Yeah, it's possible from here to here. You can connect, or PPPoE. Yeah, connecting between AS. Oh, okay. So sorry, I misunderstand. Okay, so okay, let me draw again. Yeah, sorry, I misunderstand. So you have a AS. So you have an AS border router here. You have another border router here, and then you want to connect. Yes, it's possible. In BGP, we have direct and, oh, sorry, not clear. And then indirect peering. Yes. Indirect peering, yeah. So the purpose for having a BGP peer is to have a prefix exchange, right? That's the purpose of routing protocol, for exchanging the prefix. Yeah. So if you want to do that, yes, it's possible. For example, yeah, we do peer with Kimbro here. Yeah. So yeah, you can do peering with Kimbro, and then that peer is not directly connected. So Kimbro is there, many hops away, and then we can set up a BGP connectivity, BGP peer with them, and then we can retrieve the BGP prefix from them, and then we can do marking like bogons or yeah, other stuff. Next, BGP VPLS. Wow, this is very advanced topic. Oh, Nicola. Oh man, you're still awake. Oh, what time is it in Sydney? Wow, must be very late for you guys. Oh, 12:35. Wow, very late. Wow. Well, BGP VPLS, I think it's much more advanced than what we are talking tonight. Yeah, because BGP VPLS requires you to run MPLS. Yeah, so this makes things worse. Okay, so if you are using BGP VPLS, what you need to do is, look, guys, for those who are Nicola already know the BGP, okay, because I know him personally. Okay, so you have to run BGP here. You have to run BGP, okay, and then inside you have to run OSPF, right? Okay, you run OSPF here. You run BGP here. You run BGP. You run OSPF, okay. But if you want to use VPLS, so there is one other thing that you have to run, which is MPLS. MPLS, 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 MPLS. So three things you have to run, okay? BGP, OSPF, or IGP. Well, if you use IGP, and then one thing that comes to your mind usually OSPF. Why not RIP? Because RIP is not good. Okay, SPF is faster, has more feature, but you need to have more knowledge to control how SPF behave. Okay, otherwise it will destroy you. Okay, if you don't understand how protocol works, don't use it. Use static routes. Okay, so three things. Okay, BGP, OSPF, and MPLS. Okay, and then time of Naruvin. Yeah. So BGP OSPF, yeah, it's using control word, yeah. So I don't know if you guys are okay. Look, if you run OSPF, okay, and then you can set up one feature of MPLS is you can run like tunneling, okay? So you're tunneling from here to here using MPLS. And then one way to do that is you are using manual VPLS. So from this router and then this router, you set up a VPLS manually, and done. You're good to go. Okay, your customer can connect to each other, no problem. And then you want to make it automated, so that's why you need to have a help from BGP here. So you run IBGP. So the signaling is not done manually, but automatically using the BGP. Okay. Yeah. So that's why it's called BGP signaling VPLS. And then that one is use control word. Yeah, control word is the parameter that is used for VPLS for setting up the VPLS. Yeah, I think it's well. Maybe next time. Okay, next time. Oh, okay. Yeah. So one comment here. OSPF standard situation works nice and clear. Okay, but with equal cost when I want to merge two fiber with failover, losing flexibility. Oh yeah. I need to ensure, yeah, because TCP, if you run TCP, yeah, it has to go with the same way. Yeah, because TCP is very strict with the packet order. Okay, so if you have a big file, the big file needs to be chopped, right, into segments, and then the segments will be numbered. This is segment number 1, 2, 3, 4, and 5, and 6 and 7, and so on and so forth. Okay, so this segment number will be sent in order. Okay, 1, 2, 3, 4, 5, and then better if you send the packets in the same path as well. So yeah, so for example, this. So the path here is on, so the traffic between router 2 and 1 is using this path. Okay, so that's why we are ensuring the TCP connectivity, right? Yeah, otherwise we have reordering problem. If we are, okay, so first packet come here, packet number 1, packet number 2 over here. Yes, we can do that. But I don't think it's recommended, because the way the packets arrive here will be different, and then there will be a retransmission, and then customer complain. Yeah. So yeah, so you are mangling a lot. Okay. Not sure if better solution is available. Yeah, I think yes, a policy routing. Yeah, the way you do policy routing is by doing a mangling. Yeah, you do mangle, and then you do mark packets. I'm sorry, mark connection first, and then mark routing. Yeah, and it's something like PCC. Yes, there is a. I think there is a possibility for PCC. Yeah. How to replace old Mikrotik VTP infrastructure with Mikrotik. VTP means like it's related to VLAN, right? Like a VTP domain, right? So that we don't have to key in the VLAN one by one in every switches. That one, because VTP I think is proprietary Cisco. Oh, okay. Sorry, guys. It's I got info from admin here that time is up. Perhaps we can continue in the future. So sorry, Lucas. For VTP, I don't think so. Mikrotik has their own switches, but they don't have features like I don't think they have features like Cisco VTP. Perhaps Ubiquiti switches they have. Yeah, because they are using controller, and then yeah, but yeah, but the same thing. In the controller, you have to at least you are propagating the profiles. That's the Ubiquiti switches can do. Okay. Yeah, using VTP server and clients. Ah, okay. Yeah, very nice. Yeah, yeah. Right, right. Thank you, Lucas. Yeah, thank you for your comments. It's very informative. All right, guys. So I think time is up. Time to say goodbye. Time to sleep for those who are in Australia, in Taiwan.
Yeah.
Taiwan must be very late. Any closing from admin?
Guys, don't leave the room yet, please. Can we take picture? Can you please maybe stop sharing first, Mas Ahmad? And then,
Oh, yeah. Okay,
yeah,
so guys,
before
it's
we leave, please don't leave
a photo
the
session.
room yet.
Right, so I'm gonna take some picture of you.
Yeah, can you
Please turn
maybe
on
stop
your
sharing?
camera. I'll need
Can you
to
please stop sharing first?
open the I need to open the camera here. Make sure it's open that everybody can be seen. All right, and then don't forget to submit your feedback. Okay, if you have suggested topics, and then you're welcome to do so. Right, I'm gonna take a picture. 1, 2, 3. Yeah, thumbs up, thumbs up. 1, 2, and 3. Okay, page 1. Oh, we have 3 pages, huh? Okay, never mind. Okay, another thumbs up. 1, 2, 3. Okay, and then next page is.
Nicola, thank you for showing off your thing.
Right, thank you. Okay, guys, I think I've taken the pictures from all of you. Thank you very much. Okay.
Guys, thank you very much for your attendance. We hope this webinar will give you a good benefit and value. Oh, any sounds out there? Okay, in the end of the day, if you end up join training with us or maybe in other place, no worries. But bottom line is never stop learning, right?
Right.
So yes, keep your fight on your knowledge and skills, and see you next week. Next time.
Sometime, yeah.
Don't forget submit your feedback, please.
Okay, so I think that's all, admin. Again, guys, thank you very much for coming. We really appreciate your attendance here, and then it's time to say goodbye now, and we'll meet you in the future next week at the same time with different topics. Again, thank you very much, and then have a nice day, and then have a good rest for you guys. Thank you.
Have a good rest. Bye-bye.
Okay, bye.
Thank you.
Thank you.